Yeah, welcome. So today we will hear from Ivan Kauberg of the Pittsburgh Supercomputing Center about data-driven computational pipelines on Bridges-2. Welcome to the Pittsburgh Supercomputing Center. I guess you're probably somewhat familiar with us because I believe most of us actually are part of our user of our research and educator community, but here's a brief recap of what we're doing since 1986. And in particular, this is a Bridges-2 webinar. So again, I assume most of you actually are using Bridges-2, but so this is the system. I would like to welcome you on behalf of the Bridges-2 leadership team. So I'm Sergio, the principal investigator. And again, on behalf of my colleagues in the leadership team, welcome to this webinar. Now, our Bridges-2 webinar series is, as you see here, a forum for our community to learn and share ideas and achievements. The recent few have been focused or presented by members of our Bridges-2 team, of our PSC team, but the initial seminar was not. So we're open and we're eager to hear from all you guys to propose topics and speakers that you know of, or that, obviously could be yourselves. So just please send me email if you would like to propose future speakers, again, including your own group or including yourselves. So today we're happy to hear from Ivan Kauberg. Ivan is a research software specialist in our biomedical applications group, and he is tinkering, that's his word, not mine, with technology and scientific projects, such as, at the moment, HubMap, the Brain Image Library, and CellNet. And I think Ivan will say a few words more about that. So just finally, Q&A logistics. So the way we're going to do this is we're going to give Ivan a chance to talk for the first 40 minutes or so, and we'll reserve the last 10 minutes for live Q&A. So that means all of us except Ivan will be muted during his presentation. And we would invite you to type your questions into the Zoom chat as they occur. Now, there might be some more general ones that we will be able to answer, but then Ivan will go over the questions with Ivan at the end, and he will be able to address some of them. And if there are any left over, or maybe even additional ones that occur to you, here's his email, and Ivan has graciously consented to continue the conversation afterwards. So again, starting now, your questions are welcome in the Zoom Slack channel. And so without further ado, I'm going to stop sharing and turn things over to Ivan.
Can everyone hear me?
I can.
Okay, good. Okay, can you see my presentation?
Yes, I can.
Okay, perfect. Well, Sergio, thank you for inviting me to be part of this webinar series for Bridges-2. Today, I'm going to be talking about data-driven computational pipelines that can be run and processed on Bridges-2. Like Sergio was mentioning before, I am part of the biomedical applications group, and my role within the group is just to explore new technologies, or like tinker, like I said, learn about new things, and specifically for 3 projects. the Brain Image Library, HubMap, and SetNet. In the context of this webinar, I'm mentioning the 3 projects because for each of these projects, we do some computational, we run some computational workflows for data analysis, and that's what I'm going to be talking about. Now, what is the motivation for this presentation? It's not necessarily workflows. So one of my research topics is related to fairness or FAIR. For those of you who have been involved in NIH projects in the past, there has been a focus on fairness, which basically means that we are trying to focus on making our data available, findable, accessible, and reusable, but that also includes code. So the purpose of this presentation, of this webinar, is to show you how you can create workflows that you can use around your research code, either for your own research projects or for publications, so that you can share it with the world. So that's the motivation for this particular webinar. So the concept of workflows is not new. It has been around since I started doing computer many years ago. But the idea is that you can build a workflow out of individual tasks. Some of these tasks can be very small, can be very granular, or you can have just one big step that performs many things. But ideally, you can create a workflow that it's that can perform your research pipeline. Now, we're more used to traditional bash-like scripts when we're working on Bridges-2, where we just call a set of applications sequentially, and then it can perform our tasks. But the idea of using workflows is to just create wrappers around our traditional scripts so that we can share them with the world. Now, like I said before, the main point of this presentation is just to highlight the fact that if we do this, then we can easily share and reproduce our workflows with our collaborators all around the world. Now, there are different kinds of workflows, but on this webinar, I'm just going to focus on data processing and analysis workflows. Now, that being said, there are many workflow management systems available right now. There only used to be a few that were very robust in the past, but nowadays everyone seems to be creating their own. Some of them are very large and popular. They run on systems like Bridges-2 or some other national centers, or they can integrate very easily with cloud computing services like Azure or like AWS. So there is momentum on creating, developing, and sharing workflows in the same way that we share code on systems like GitHub. Now, like I said at the beginning, I'm part of the biomedical group. So my particular interest is in creating workflows for the analysis of large-scale biological data, whether we're talking about sequence data or we're talking about image analysis. Now, in terms of some bioinformatics workflow management systems, there are many out there. The list is even larger. Like I said, some of them are very popular. Some of you might have used Galaxy in the past, which provides a nice web interface, which you can create. You can create workflows for data analysis. But those are dependent on you running a service on a web server, or being able to connect your Galaxy instance to a large computing cluster, et cetera. When you're doing things on some of these tools that I'm going to be talking today, like Nextflow and SnakeMake, for example, you're going to be able to use it directly and very easily on systems like Bridges-2. I want to highlight that the main reason that I'm talking about today about Nextflow and SnakeMake is because these are one of the 2 most popular ones, at least in terms of a community building workflows behind it. So that does not mean that the other ones are not useful. They're just not going to be mentioned in the webinar today. Okay, so how many types of computational workflows we have? Well, basically we have 3. We have your very traditional procedural workflows, similar to the bash scripts like that we can submit to Slurm currently on Bridges-2, where the main focus of our computation is the procedure itself. There's very little emphasis on quality control in terms of the data or the data input and output. We just care that our program runs, and then there's an alternative step or some quality control that happen after a procedure is done. Then you have model-driven workflows, which are very traditional. We probably all used them in the past to run some kind of ODE models or PDE models. These were very popular 20 years ago with software like Stella. And then we have the data-driven workflows where the state of our data is what's really driving the computation. And that's what I'm going to be talking about today. So in terms of model-driven workflows, the typical example is Simulink for MATLAB, which is supported on Bridges-2. You can do this kind of modeling on our systems. The next one is, for example, Airflow, which is a procedure-driven workflows management system that we do support using Bridges-2, but this as part of HubMap. This is sort of like a private instance that internally uses the RM compute nodes for data processing. But like I said before, the main focus of this presentation is to talk about data-driven workflows. And the main difference between the data-driven workflows and the other types is that the state of our data is what's driving the computation. So at any given point, the quality of our data is, it does not meet our standards, then that can lead to the termination of the computation. So the data is the main protagonist in this kind of workflows. Now, so the first tool that I wanted to talk to you about, and is the one that I really want to highlight in terms of this webinar, is Nextflow. So Nextflow is a tool that supports multiple programming language, but has a domain-specific language that you have to write your tools with. And the main feature for Nextflow is how it scales for large data sets. So you can potentially, assuming that you have local resources, you can create a Nextflow workflow that works on your laptop that you can scale up to a small server. But ideally, in terms of research, you could bring it into Bridges-2, and then you can use any kind of resources, either like extreme memory nodes or regular memory nodes, or you can use GPUs with Nextflow. So it scales really, really well for data-intensive workflows. Now, another reason why Nextflow is really popular is because it uses container technologies, right? So you can either use Docker or you can use Singularity to run your processes. Now, the main benefit of doing this means that you don't have to wait for the Bridges-2 team to install a piece of software. You can build your own containers and push them to your Scilabs or Docker Hub account, and then you can pull those containers as you're doing computation directly on Bridges-2. And it also offers a robust error handling which some of the other systems do not provide. So it can be quite complex. So there are many pros of using Nextflow as a management tool. Portability is one of the key features, at least for me. I can develop a Nextflow workflow on my laptop and test it on a small data set. And then I can bring it back into Bridges-2 and then use it to test or do an actual workflow computation on some of the HubMap large data sets or the brain image library data sets. So the portability is one of the key features for me, and also scalability. Right, so I can on my laptop, I can maybe process one image at a time, but I can scale it up as to how many cores I have available on a compute node that I have access to. So that's another reason why Nextflow is very popular. Just like with Slurm, you just need to change a few parameters in your call to Nextflow to scale it, rather than you having to rebuild your code. Now, the other reason why Nextflow is very popular is the active community. So now that being said, there are some cons in using Nextflow as your management platform. The learning curve being one of the largest problems. It is so flexible that sometimes even starting from trivial examples can be complicated for someone who hasn't written workflows before. So this might not be the best management platform to start learning about workflows. But then again, you choose the platform that you like. And in terms of Bridges-2, if you want to use some of the shared resources like RM Share, you do require an additional configuration to run Nextflow workflows, which is a non-trivial setup, but that we can share those configuration files with you so you can use them efficiently. Now, like I said before, one of the biggest assets for Nextflow is their community. They have one of the most robust and stable collection of workflows, specifically in the area of bioinformatics and genomics. So there are many groups that are currently working at Bridges-2 that are using Nextflow. And all they're doing is they're just pulling this existing workflows from NF Core and then just using them on Bridges to process their data. Now, what do I need to create a workflow? It's sort of very straightforward. You need a workflow script. You need some configuration files, especially if you're going to run them on Bridges-2. And then you need your input and your input data. It is very straightforward. Even though the amount of files needed to run a workflow is somewhat small, some of the workflow scripts can get really convoluted and complicated. Now, that being said, we provide you with the Nextflow binary on Bridges-2. So it is available using LMOD. All you need to do is do module load Nextflow, and that will put the binary in your workspace. And this is a very simple example of a config file. Basically, you're saying, I want to enable the use of containers, and then you're defining your process to run on the RM queue. So you have to let Nextflow know what partitions you have access to before you're able to submit a job. So to my understanding, most people have access to the RM shared partition. So this should be a very basic configuration script. Of course, you can change it to extreme memory, to RM shared, and RM small. So this is an example of a Nextflow workflow. This is the RNA-seq workflow, which is very popular among Nextflow developers. And we actually use it internally for some of our research projects. So what do you really need to do to run this workflow on Bridges-2? Well, it's really very straightforward, because the workflow itself has been built, maintained, and taken care of by other people, and we trust these people building this workflow. All we need to do is just pull it from the web, and there's just one command that will pull all the necessary files locally, and it will run it based on our input data. In this case, I am just running the test profile, so it's going to run it on some test data. But the main difference between this and doing an actual run of RNA-seq on research data is just changing the location of the input data. And this will this will done an RNA-seq validation with a reference that you can change to. So again, Nextflow is very flexible. In this particular case, you can see that I am actually submitting this script to RM shared. That is because I am running the Nextflow manager on RM shared. But if you remember the config that I shared before, it was telling me to use RM, meaning that I'm going to have one working job on RM shared, which will control the workflow manager, but every single job spawned by this job will be running on RM. Okay. So that was about Nextflow, which again, very powerful. The community, it's very large. If you're doing genomics, it should be the very first place for you to start looking for a pipeline. An alternative is SnakeMake. It is very flexible. I personally use SnakeMake for workflows that are not that are more linear, and such as, for example, background subtraction on noisy data. And for more like nonlinear complex workflows, SnakeMake can be an overkill. But then again, there are some pros of using SnakeMake. As you can see, these are very similar to the benefits of using Nextflow. And in reality, if you see the list of the other workflow managers that I shared before, they all sort of share the same pros. Now, the good thing about using SnakeMake is that it integrates seamlessly with other software tools. So if you're going to be using tools that are already available on Bridges-2 as a module, as part of LMOD, SnakeMake makes it really easy for you to run a workflow. So you can just like do a module load of all the tools you need, and then just have SnakeMake connect all of the tools together into a simple pipeline. SnakeMake also supports containers, but it is non-trivial to write snake files that will support this. Now, again, the learning curve, just the same thing with Nextflow. If you have never written workflows before, it can be a little bit tricky. However, I prefer SnakeMake because the domain-specific language kind of looks like Python. So if you're a Python developer, SnakeMake is a better start than Nextflow, which is Groovy style. It can be a little bit more complicated if you're never written any of those. Debugging is a problem with SnakeMake. The debugger for SnakeMake is not as informative as it is with Nextflow, and that's another reason why people prefer one over the other. There is a community for SnakeMake. Workflow Hub is one of these communities. However, this is not geared only towards SnakeMake. There are other workflow managers that are supported by this community, whereas the one for Nextflow is just for Nextflow. Okay, so what are the parts of a Snakeflow workflow? Very similar to the other manager we talked before. We just need a snake file, which is the name provided to the main script for SnakeMake. And then we need a configuration. Again, we need this configuration so that we're able to submit the workflows on Bridges-2. And your input data. And there's some optional information in case you want, you want your workflow to create files on disk, or you just want some standard output. And then there's some environmental specification, because SnakeMake, being Python-like, it integrates very nicely with Conda. And as you know, we support Conda on Bridges-2. So in order to set it up, you just need to load Anaconda 3 on Bridges-2, and then just install the SnakeMake package with pip. And that's all you need to do. And that will install the manager needed to be able to submit SnakeMake workflows on Bridges-2. So the installation is very straightforward. So what are the main differences between SnakeMake and Nextflow? The only way that I can summarize this, it's very similar to the discussions between which the better editor, Emacs or VI. It's an issue of preference. Like I said, I particularly like SnakeMake for smaller, non-linear workflows, and Nextflow is so much better for more complex workflows. It's an issue of preference, but if I wanted to have my workflows have more visibility in the research community, I would more than likely port my workflows into Nextflow. It seems to have more momentum than SnakeMake at the current moment. Okay. So what's the situation? Like I said, it depends on multiple factors. But as someone who has been using this for a while, at the end of the day, it's just user preference. With all of this workflow management systems, there are a lot of cons that I'm going to talk about it at the end. So at the end of the day, it's just an issue of selecting the one that works for you. Okay, and so far, the two of them that we have talked about are fully supported in Bridges-2. Okay. Oh, I see questions. Wait. Okay.
Yeah, this seems to have to.
Oh, yes,
do
yes,
with the,
yes,
yeah,
yes.
next flow example.
Okay, so no, so the example that I provided, and I don't know if you noticed, but wherever you see the GitHub logo, that means that that script is available on GitHub. I'll share it with you at the end. But that example, let me see if I can go back quickly. That example is doing a test. So I'm running a test. So it's using some internal data that comes with workflow, with the workflow itself. So it's using a small data set to test the workflow. I'm not doing a full run. Okay. And I can definitely add a script to the repository that includes the processing one of our HubMap data. But the reality is that a full run on a large data set will consume a lot of your allocation. So that's why the examples are just showing tests on very small data, because I really don't want to consume your allocation just for testing the workflow managers on Bridges-2. Okay, so yeah, we talk about the differences, and like I said, it's user preferences. But now, one thing that I want to mention is that before we talk about domain-specific languages, meaning that both SnakeMake and Nextflow have their own kind of files and scripts and their own language to build them. So here comes Common Workflow Language, which is a specification for workflows that is trying to be agnostic. It's trying to be platform and engine agnostic, right? So the idea is that you can write, you should only learn how to do this in CWL, and somehow all these different engines, Nextflow, Snake, Make, and Galaxy, they can all read and interpret these workflows, and they can run them in their own engines. Now, we use Common Workflow language to create the workflows in HubMap. So the ones you see at the beginning with Airflow, that's the technology that we use. So the main issue with Nextflow, even though it's really powerful, it tends to be geared towards genomics and bioinformatics data. But the Common Workflow language and its tool, CWL tool, tries to be a little bit more generic. So you can sort of create these very generic pipelines that are not just necessarily genomics related, and that will run on many systems, including Bridges-2. Now, in my own bias, the two main important things for the Common Workflow language is that you have a clear declaration and specification of your inputs and outputs, meaning you can specify data types. That is really powerful instead of having these sort of generic inputs and outputs, especially if you're doing data-driven analysis. At any given point in your computation, you want to keep track of the data, the right data type, the right format, the right data structure. So you have more flexibility in trying to define these. And validation and verification. You can add testing into your workflow, and it will test your data. It will test your results, just to make sure that every step of your workflow is valid before proceeding into the next step. And again, you're going to notice that the pros are very similar, right, to the other two tools that I talked before, but flexibility is the most important one, right? Because the point of a Common Workflow language is to be platform and engine independent. In an ideal world, you would just write your CWL file, and then you can submit it to different platforms, whether on the cloud or Bridges-2 on your local systems, and they should all be able to recognize your workflow and run it accordingly. And then again, the community and ecosystem, it's also a pro. There's a large community of practice that supports CWL. One very specific one is Galaxy, for example. Galaxy supports CWL. Now, what are the cons? The complexity. Again, since this is trying to sort of be like a generic language that support any kind of workflows, you can sort of like see that even writing trivial workflows can take a lot of wording. This is sort of like a very verbose language. So SnakeMake, very simple and trivial. And then you have the total opposite with common workflow language, where you almost need to define every single variable in your workflow. Even though it's trying to be a generic language that is going to be supported by everyone, there is limited support, right? Like not every single management system supports CWL. However, they provide with their own tool called CWL tool. CWL tool is supported in Bridges-2. Again, it's a Python package, so you can just load Anaconda and just install it on your user space. And with the CWL tool, you should be able to run any pipeline. Now, I want to make a sort of a secondary note. I personally run my own mini conda distribution in my home directory in Bridges-2 because I play a lot. I tinker around with code a lot. So if you have something like a small mini conda distribution, you can install CWL tool as well. It's part of CondaForge. So you can alternatively install the tool that way. Okay. And like I said, when we summarize everything, Nextflow, SnakeMake, and CWL can be used to run workflows and Bridges-2, and it does it very efficiently. Of all the tools that I have personally used in the last 2 or 3 years, these are the tools that I use the most, and I find them the easier to learn. Again, there are other very popular workflow managers out there. For example, Terra is very popular right now, but Terra is totally cloud-based and has nothing to do with Bridges-2. One of the reasons why people like Nextflow is because even though we can use it to scale up on Bridges-2, it can integrate very seamlessly with AWS. So that's another reason why people like it. They can just submit it to different clusters, either private or public, or they can submit it to Azure, and they can produce very reasonable results. But the bottom line in relation to the first slide that I presented to you is that the benefits of sharing your workflows publicly, especially after a publication, outweigh the cons of any workflow manager system, right? So think of the scenario where you publish your article, you publish your raw data, but now you can also provide a workflow that can very easily reproduce all the results of your article. And because it's using containers, it should be able to run on a laptop, on a small server, or on Bridges-2. But the bottom line is just choose the platform that suits your community the best. Now, one last note, because this is the critique I get all the time when I talk about workflow managers, and is that there is some overhead using this kind of system, and it is. I am presenting you with a benchmarking of a very trivial example, which is just producing random strings using the GNU Fortune app. And you can see that if I were to put that on a workflow, in this case SnakeMake, it runs 10 times slower than just calling it directly on the system. And that it's an overhead, true, but like I said, the benefits of using a management system like this outweighs this kind of overhead constraints. So I think we're at the end, and all of our workflow examples are going to be available here. I think the repo is private right now. I'm just cleaning it up a little bit, but by the end of the day, you should have all the scripts available there. And it goes from very trivial examples to more complicated research examples, but none of them are using real data. Like I said, because if you were to run any of these in Bridges-2, you might just consume your allocation, because these are non-trivial workflows. So I'm at the end of my presentation. If anybody has questions, I'll be gladly answer any questions. Let me look at the chat.
Okay. Thank you very much, Ivan. So looking at the chat, I think Pradeep has a follow-on. And he also has his hand up. So Pradeep, I think you can unmute yourself and
Yeah, thank you, Sergey. And it was very educational. I learned a lot. So what I'm trying to understand is most of our workflows for neuroimaging processing are Python libraries, you know. So by that I mean basically platform basis, right? So why should I use the? Sorry for such a direct question. I'm just trying to figure out the benefits of spending time in maintaining such workflows.
Well, the main benefit of creating a workflow is for you to be able to share your pipelines with other groups. So if you have your Python libraries and they aren't available on, say, a system like PyPy, that you can easily create a workflow that will install them locally, or you can put them in a container, and then you can share that workflow with other collaborators, and they should be able to run them out of the box if set up properly.
We
That
can
is-
do the same with Python libraries, right? Most of my pipelines completely in Python.
Well, yes, and no, right? So one of the main issues we have in bioinformatics is the usage of legacy Python packages, right? So you may have Python packages that are only available in Python 3.10, and some of them that are available on Python 3.2. So having a very complex workflow that uses multiple containers will allow you to use the proper version of each library, avoiding conflicts. And this is something that happens all the time when using Python libraries. So also the other main benefit of using this is that you might be using the latest libraries today, but nothing prevents it from changing in the near future. So if you want your pipeline to still be useful and reproducible in, say, in the next couple of years, putting them in a container and share them on a workflow is a guarantee that they will be able to run in the near future.
Yeah, don't want to take up more time. The way I have been solving this problem was to maintain my library such that it works across different versions of Python, as well as solve the reproducibility issue in a more numerical and technological sense. You know, what do you think about it?
So I understand what you mean. So we had an issue before in the past where we are the maintainers of our own packages, but we may have dependencies of packages that become outdated, and that's the main reason why we migrate towards containers. Because you know, the typical example is when we jump from 2.7 to Python 3. Where we had some legacy Python packages in 2.7 that we still needed some level of support. So using containers and workflow technology was at least a short-term solution to the problem while we found a long-term solution. Again, the main benefit of using workflows is reproducibility, right? Is to be able to put a container out there that, a workflow out there that people can just download and use out of the box. That is the main benefit. And if you use Nextflow, you'll realize how trivial this is if the workflow is well maintained and robust.
okay, so I think, and Ivan, Pradeep, if you want to continue the discussion, you have Ivan's email, so yeah, you can go on. And we have another question. I believe this person identified by a number also had something in the chat, which seems to go to RM shared, but please ask your question.
Yeah, hello, Ivan. We talked before. My name is Paul Cantalupo. I'm with Uma Chandran at DBMI, where we were running the RNA fusion pipeline last year, and we had some problems with inefficiencies on PSC where it basically used up 10 times the number of SUs as to what compared to HTC, because every job had to run on a completely full node. And so so I just wondered if you fixed those configuration problems, because you were talking about looking into that more, and I didn't yeah, just can you give me an update as to what's?
Yes, I will share with you the scripts that will fix that issue.
Oh, okay. And then can you specify memory? Because I think there was a 2 gigabyte memory limit per core.
Yes,
Okay.
yes, you can specify, that is the only issue, that you have to specify the memory based on the number of cores. So that cannot change as part of your configuration.
Ivan, in your talk, you kind of alluded to this, but I wonder, like in the version of the slides that we will publish, whether you could maybe insert one where you show like what the script is,
Okay, I can do
example
that.
of it.
I can do
Yeah,
that, yeah.
because maybe other people would find it beneficial too.
Okay,
Sure.
thank you.
Okay, guys, floor is open for questions, free fire, at will. Who has more questions? Just unmute and ask. Or you could also type them into the chat if you want us to have a written record. Floor is open.
Yeah, there's gonna be a record of this talk, and it's probably gonna be available.
Hey, Yvonne, another question.
Yes.
So do they help, what do you call schedule? Do they help with scheduling these workflows?
What do you mean scheduling?
As in oftentimes to efficiently process large data sets, we choose different chunks of data sets to process under each individual parallel script.
Okay.
So I'm
Okay.
wondering if you can specify some logic with
With Nextflow, you can. With
Okay.
SnakeMake, I don't know if you can. I've never done it. With Nextflow, you have the possibility of configuring each step in your workflow. So you can use, if you have access to large memory nodes, you can request more resources for very specific steps, which makes your computation a little bit more complex, your configuration file, but technically it is doable. Yes.
Okay, more questions. I posted again the link where a recording of this webinar along, with the others are posted or will be posted. Other questions?
LAPTOP IUA151DH disconnected.
Anybody else? Is there anything else you would like to add or explain or?
Just one thing, use workflows. They're amazing. They're the future.
Okay. Well, if questions occur to you as you think about this stuff, just let us know. Again, Ivan, you're agreeable to
To answer, yes.
receiving and addressing any questions, right?
Yes, that's correct.
Okay. Well, in that case, I think, let it all sink in, and thank you all for attending. And Megan, can you stop the recording? And yeah, watch that link for the, maybe give us a few days and then the link should appear. Thank you very much.